working.
It's working, right?
Okay.
Yeah. It'll work. Go.
So, hello. Oopsie. Okay, I
Go
forgot.
down and make this. Stop it. Okay, start again.
No, I'll cut it.
Okay.
No, move on.
Go and make the video and upload it. Okay, don't forget to upload.
Yeah, I would upload, of course. Hello, guys. So today we're doing some more Python, and so today we're doing So today we're gonna be doing some sort of math. We're gonna pronounce some beautiful math in it, such as these fractions. It doesn't have to be like this. It could simply be in form, just however it converts you. However it converts you, this video will help you if you want to create such as tables. So first of all, you need to know what are loops. Loops. So this video is going to be about for and while loops. So, and that thingy, of course, you might not know why this thingy is red, but if it's not for you, that's okay. Because for me, it is. So anyway, let's go to a new Jupyter notebook. New Python 3. Hey, the freak. So anyway, let's just start typing in. Blah, blah, blah. Okay, so to do a loop, we first have to assign a variable. You don't have to, you can assign. So let's just start with the basic loops, okay? So let's start. So let's start with doing for loops. Yeah, so this video is anyway going to be about for loops. This map thing is about for loops anyway. So let's start by creating some for loops. So to start a for loop, we just put in for. Then we put in any sort of thing as long as it doesn't have a space within it. Because then we're just assigning variables. Now, don't use this variable to do the loop over again. Or else it'll just do the last part of it. The last part of your code of the output. So you won't really want that, right? Yeah. Okay. So let's just for now use the variable name I, okay? For I in. So you see, this is the thing. You can assign a variable to a string. You see, this for thingy only assigns to how many characters are in a string. Yeah, okay? So one way is A equal to. So we have to put a string because it can't use integers in it. You can't use the amount of numbers in it, actually. It is true. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, if you're also doing another thing, don't get confused with this because Python includes numbers within strings, okay? So don't get confused. And then we can put A. After that, we have to put this colon. You see how it does this indent automatically? Now, if you don't put an indent near here, then Python will put in an error. Example, I'll show you something. It may not put an error, or it can be a forever loop. I don't know. Actually, kind of forgot. Hash. See, it says expected an indent block. So you have to put tab. See, hash. So you see this. So let's just go over this loop. So we are printing this hash and how many times of how many letters this thingy is using. Get it? Yeah, that's how it works. We're printing out this hash and how much letters and how much characters this string is holding. You see, this string is holding 10 characters. So it prints this word this string has 10 times because this thingy has 10 characters. Get it? Now, what if you don't want to always have to assign variables? Then look what you can do. You don't have to assign a variable at all. You can directly put the string here. Now it'll again put in the same result. Get it? So yeah, that's good. So now, one more thing you got to learn. You got to learn about this new logical operator you can use. It'll help you in many Python things. Now, for now, we're just going to assign a variable or anything. Okay. B equal to 2. Now, so you really need to know about this dot format thing. You can watch that in another time or something. But for now, just listen, please. Even if you don't get it, actually. Because I'll tell you about that later. Right through this. Then you need to understand. So let's put in these sort of curly brackets and we don't put in anything in it. So now let's just ha 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 ha. Now don't worry if this is touching because it does nothing, okay? So now it's where the dot format is used. Dot format. Now since I'm using the Jupyter Notebook, localhost AAA, you can put in tab and it'll autocomplete for you. Oopsie, tab. Format. Now you see these lists of options. So you can click on the option you want or just use the key arrows and press enter. Now, so let's just add in the thing. So what do we want this thingy to be? 2? Yeah, 2. Now you must be wondering, I could have just still put 2 all the time here, right? But wait, you'll see the trick. Let's just put the B here. So now if you run this, it just puts in 2, 2. And as you thought, we could have though just put 2 here, right? It brings up the same answer. But if you think so, if you want the number to change, then you need these things. Like example, if you want 2 to change to one more number within this loop, then you have to reassign throughout. Then you have to make it reassign throughout the thingy. Now I'll show you what that means. If it looks too complex in your mind or something, or you could just just makes the speed of the video lesser because I think I'm talking very fast, kind of. So 2 plus equal. So you see, you can put this 2 plus equal, or you can put in 2 equals to 2 plus the thing or whatever. So for now, I just like this because I don't remember if it's plus equal or equal plus. That's why I just like to do it like this. Even for you, if it is for beginners. For beginners, this is the best. So 2 equal to 2 plus 1. And then again, this whole loop occurs until it's false. Even though this is a for a loop. Then assign to literal. You see, oopsie, silly me. It was supposed to be the variable. This was supposed to be B. See, now, just to make it more readable, I'm just going to put some space here. That's just a new cell. I keep on forgetting to put in the cursor. I know, it's a bit coming. So, right now, if you can see, this 2, 3, 4, this 2, 3, 4, 5 is counting by 1 more. Because we put in this reassignment that B equal to B plus 1 throughout the whole thing. Throughout how much it can go. Get it? And remember, you can still just go back into the video. And please don't worry about this red thing. Yeah, I don't know what's happening. What is happening? Okay, so in one more thing. I mean, this isn't really used within the video, but I'm just telling it for extra information in any case. You don't really have to do this whole thing. That's what I wanted to tell, actually. But it only works for 2-digit numbers if you don't want it to be like this. So look, you didn't really have to do this whole thing. Instead, look at this. We put in this variable for I, so we can just put in the I here, and this whole thing would have come. Except that it only comes for 2-digit numbers. Or look what happened. It'll put in 1 0. Yes, so see, it only works for single digit. So that's just for any extra in case use. So you see, for 2-digit numbers, it's not so good. Okay. So let's start creating this beautiful math thing. Okay. So you see, I feel like it's just the kernel is too much. So let me just restart it. Restart the kernel. You see, all variables will be lost, but I don't even need the variables, of course. Cut. Never mind. Okay, that way. Okay, so anyway, let's assign a variable. And make sure that's not a keyword, or else the function will become a keyword, okay? Like, even though print is used in, like, these sort of things, and you get this, if you assign print equal to 7, you see what will happen? Int object is not callable because the function has changed. And now, if you do, it will become 7. So anyway, let me just restart the kernel. You see, even if you change the value of print or make it a new function, it'll take a long time because it's a built-in function, right? So you don't know how it exactly programs. So for any cases, you could just restart the kernel. Then it'll forget everything. Okay, let me just cut. Maybe that's better. Okay, so let's just assign a variable called A. So, what type of table you should do? It can be anything, literally. So for now, let's just try phi table. Phi. So first, let's try multiplication tables. A equal to 5, right? So let's just run that. Now, let's do the loop. For I, and let's see. So is the table going to be from 5 times 1 to 5 times 10, or 5 times 1 to 5 times 20? Let's just try from 5 times 1 to 5 times 20, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You must be thinking that it literally makes no sense to type this whole thing, but it's the only way to do it, literally. Now, let's do the thing. So let's do the print formatting. So, we want to print in phi table, right? So let's do phi times. You see, I'm just using x for now, so don't think that I'm the only one who has a sudden magical keyboard or something. It's just the letter x. But for now, let's just use the times. But if you don't get it, then let's just do phi times x. Phi times. So here comes the print formatting. We put it in those curly brackets. Dot format. You see, sometimes it takes a long time for the tab to work, literally. And if your computer is a fast one, then maybe it'll take a shorter time. So, phi times A. And tell me, this is supposed to be a 1, literally. It's supposed to be a 1. I don't have to restart the kernel for everything, okay? Guys, don't think that I'm dumb. Anyway, Now, so in each loop, we're going to change the value to 1 times more, right? So let's make it that a equal to a plus 1. Okay? A plus 1. See, now it'll print it 5 times 1 plus 5 times 2. Oh, I forgot something. We got to put in the values, of course. Oh my god. We got to put in the values. Why did I forget that? So now, so now here comes the part. We don't know. So now we have to put in a new variable assignment. But then how will we know that it should be the answer? Here's the trick. It includes a as a part of the value. So let's just put the b as the variable. B equal to a divided by 5. Oopsie, not 8. I mean 8 times. You see, in programming, it's what they use this. And if you don't know how to print that, then just ask your parents or something. Or I'll just tell you right away. You just have to put in shift 8. Anyway, it doesn't matter. So shift star 5. You see, because it means 1 times 5. 2 times 5 throughout the loop. 3 times 5 throughout the loop. It's like that. Now, look at this. So now, we have to put in something here. Now, that is going to be B. And B is a value that includes A throughout its value. So if A changes here, then B also changes here. Get it? Because it's a part of the value. See? Oh? So does that mean that it's only the first one? Sorry, guys. Okay, I just tricked you probably. So it has to be B equal to A times.
Remember?
Oh, you see, don't really worry about that, okay? Because this is the thing. You have to restart your kernel and run it again. Why? Look, this is just the same as called something string concatenation. It's where you print a string and it keeps on running by itself. And it keeps on adding. This is the same thing. We want it to be from 5 times 1 to 5 times 20, right? But instead it adds 5 times 20 more, and it adds the 1 to the 20. So instead it prints from 5 times 21 to 5 times 40. Now you okay. If you don't get it, I'll show you what it means. You see, we're starting from 1, right? Such thing. But now it'll start from 21 since we're again running it. Remember? You see, loops go out throughout your computer. That's why it's happening. So if you wanted to do it the proper way, then you have to restart the kernel. Sorry, guys. Kernel ready. Shift enter. See, now we got the perfect table. 5 times 1 equal to 5. Everyone knows. 5 times 2 equal to 10. 5 times 3 equals to 15. Just like that. Now, what if you wanted to print out another table? That's pretty simple. Look, all we do is just change the variables and stuff like that. Instead of 5, we just change it to 6. And instead of 5 here, we just change it to 6. And instead of 5, we put it to 6. See? Oopsie, I forgot to restart the kernel again. Restarting kernel. Kernel ready. See, now 6 times 1 equals to 6. 6 times 2 equals to 12. Now, if you have a problem with this, then, just go back into the video.
Did you realize?
No, So, anyway, let's just move the webcam, probably. Not the webcam, I meant the camera. Not the camera, I meant the webcam, probably. Right. Okay, I think this is fine for now. I think this is fine. So now, what if we wanted to do division? not that easy, but still kind of same process actually. If you wanted to know, even division uses this sort of same process, kind of. Now, let's just put in some variables, okay? So which way do we want it? Do we want it from like, so first of all, which division table are we gonna do? 6 division table? Okay, pretty much. Just try any actually. You can try. It just works with any actually. Now, if your computer GB is just like 4 or 5 or 6 or something, then don't really do exponents. Because then the kernel will become full, because then your computer might get too much. That same thing happened to me because my computer is only 4 GB. Okay, whatever. So anyway, just let's type in some code. For I in let me think. For I in what can it be? So from where do we? So how much long is the table gonna be? But first of all, let's discuss from where is the table gonna start? From 1? Is it gonna go from up or down? For now, let's just do from down. So how long is it gonna be? Maybe 20? Maybe the division. For now, let's just do 10 because division is really hard to stuff in your mind. 10. Silly me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now don't think that just has to be 10 or something, because then it even includes this thing has 2 characters, okay, and the space. So anyway, let's just put in 0. You should probably know about this. Print. So we want it to be 6 division table, right? So since this is division, the first number has to be the one with the dot format. So you can put it divided. You can put it in letters or numbers. In letters or like symbols. You can put it in a percentage. For me, I like percentage more because, it looks kind of just like a little bit slanted division sign. That's why I like it to use it, even though this is more popular. Yeah, so let's just use it for now. For me, I like it. Okay, so, and also one more thing. You don't really have to do that. You must be thinking that I was kidding to use the dot format, but for me, it never usually worked. So let's just put in b equal to 6, a equal to 6. Now, you must be wondering, why am I putting in 2 variables with the same name? You understand as I tell you the loop, okay?
147 minus 36.
Could you be a little quiet? Amma, could you be a little quiet? I'm creating a video.
Same numbers we have to add it. Okay.
Amma.
So how much you got? 193.
Amma.
Plus 8. Then
Can you be a little quiet? I'm creating a video.
I'm sorry, Mama.
So anyway, guys, so let's just start putting in this thing. So we can put in any of the things, any of the variables because they're the same value. So let's just put A. Well, I'm not really sure if this is gonna work, literally. You must be thinking that that's crazy. Just anyway, equals to let me just put in B. Plus, I have to change the value because 6 divided by 6 isn't gonna be 6. I'll just change it to 1. So anyway, let's just So anyway, let's just see of how we can put the division. So we want this 8 to be plus 6 since we're doing it from down to up. right? And we want it to land until 10 times, right? We don't have to worry about that 10 times because we know it's anyway going to execute 10 times. So, A equals to A plus 6. Now, you see, if you just put in the value, then it's not gonna execute all the time, right? Because then it's not the variable name which has already changed, right? So, anyway, and now B equal to A, and in division you use this type of sign. But if you use that type of sign, then it's gonna put in decimal point numbers. Because, this normal division type prints out like float. So we want it to be integer, right? Then let's just still put 2 slashes. Because that means floor division, which is the integer thing. A divided by 6. You see, that's why it never works for me. That's why I'm telling you that it never ever works for me. Or is it? Yeah, that's because strings can hold anything and it doesn't change the stuff. Yeah. So it never really works for me. A slash B. So now that we got the perfect division table, we know that 6 divided by 6 equal to 1. 12 divided by 6 equal to 6. 12 divided by 6 equal to 2. 18 divided by 6 equal to 3. Plus, don't worry if my mouse is like looking a little different from the areas of where it's moving. Because it's just a high contrast one. Anyway. Yeah. So anyway, 18 divided by 6 is 3. So we just printed out a division table. Now, what if we wanted to do it from to down? Now, that's easy, except that it includes a little bit of multiplication, which we don't really want, right? So then we can just use the before division table we want. We did. So 6 times 10 is 60, right? So now we can reassign the value to be 60. So you see, multiplication and division go out perfectly. Get it? So, 10, right? Oh, and remember, B is not supposed to be 1. Never. Because guys, 1 is not that. Now, I actually got an idea, kind of, guys. I actually got a beautiful, splendid, cheating idea. I mean, it may not work, of course. B equal to B plus 1. Now, you must be thinking, how? Probably won't work. So that's because I changed out the values. So anyway, look. Now, this is also kind of like cheating. Why? Because we know that each time is anyway gonna add up one value, right? But if you want it to be normal with some skip counting, then you have to put in normal. Get it? Because then you'll be adding it plus 12. Get it? And then this will be a wrong thing. Get it? So then we'll have to do A slash 6. Now it'll be proper. So this is like a less cheating way or anything. Because those division tables are here wrong. I mean, those are easy. So anyway, actually multiplication is easier than division. I can tell you that. But anyway, it doesn't matter. So we wanted to do from top to bottom. Well, that's actually pretty easy. We'll use this multiplication table we made. 6 times 10 is 60. So since 6 times 10 is 60, it's just the opposite. So 60 divided by 1 is 10, right? And 10 times 6 is 60. So let's just put in 60 here. Oopsie. 60. Okay. So now that we know that this b value is going to change by the time, so let's just assign b equal to a slash like a slash 6 or something. Yeah, a slash 6. Now we must be wondering, I could have also just done the same thing before. But you see, it's actually less tiring. You see, if you put in a new division table with the table 6, we keep on have to reassigning, right? Now that's pretty more tiring, isn't it? Yeah. Okay. So anyway, so now that we have to put it minus 6. Now to do 60 divided by 6 equal to 21. Huh? What that? Or is it a kernel problem? Looks likey. Oops, silly me. It can't be like this. Or is it true of something else? Okay, I think it's just supposed to be 10. Yeah, for now, let's just put it 10. Because I don't think it'll work. I think ace... let's see if the same problem occurred the last time. It didn't. After all, we've just put in the same value. So anyway, we know that we print out a division table. Now, I thought that let's just experiment and put in a slash 6. But that didn't work out. Because I don't know why, but it looks like as if it multiplied, kind of. Yeah, it didn't, kind of. So anyway, so let's see how this program runs. B equals to 10, A equals to 60. We executed those variables, right? For I, it 1, 2, 3, 4, 5. So this is the amount of characters that go in, which is 10. So that's why it was like 10 times, okay? Print, we don't know what's going to go in here because it'll be like 60, minus 6, all those times, right? Divided by 6, which is the type of table we are doing, equal to the answer, right? So we put dot format, so here it got to be A. And here it got to be B. Now, you must be thinking we could just print the values, but remember, this is a table. So A equal to A minus 6. So then the values will change according to the type of question it is. And the answer will be correct because we are doing the exact division here. Yeah. Silly me. Why did I put B equal to B equal to A times that? To bring up the same answer. And then we put in B equal to A slash the 6. Since A is already executing throughout the loop at the same time, right? Yeah, so that's true. And so it looped the thing. The thing. Okay, that's funny. The thing. Now 60 divided by 6 is 10. We got what we wanted, right? So now here comes the part. If you have a good amount of memory, then I'll just show an example of how it can be kind of. I don't know if it's gonna be how it's gonna be kind of. But I think I do remember. So let's just use the same type of thing and program we used here. CTRL-X, CTRL-V. CTRL-V, because it's going to be the exact same. There's no change in it, actually. CTRL-X, CTRL-V. Okay, so now that we're doing some sort of exponent table, we're doing this. You see, to calculate exponents, in Python, we put two stars. And even this has to be 2 stars. And then I can't really run this, but I'm just showing you a sample of how the code would look like. If your amount of memory is more than mine, because mine is just 4 GB, such as 4 to 6 GB, then maybe it'll work. I don't really know how much GB it requires. But if your computer has like a good space amount of GB, then it'll execute. Because for me, I don't have enough. But how did that work? What the heck? Oh, how did that work? Literally, I never knew that it would work. But does that really matter? Anyway, it works. So to this sort of power, I don't know how it exactly works. Looks like some sort of magic or something. So anyway, this kind of looks like too much, right? So let's just put it in halfway through. That would be better. So anyway, we know that 6 to the first power equal to 1. You see, if you don't know the types of tables and exponents, then you can actually search in Google. 6 to the second power equal to 64. 6 to the third power equal to 729. You see, these beautiful tables you can create. Now finally, let's create some sort of fractions. You can do it either ways, actually. And for a more readable way, let's just do it the proper way, because the other way, there is no way to do it. So anyway, let's just put in the code. D. A equal to A. What type of fraction are we going to do? You see, fraction is the same as division, right? Then we will do maybe A equal to 6, okay? We're going to do some sort of fraction table of 6 to times 6 by 1 to 6 by 10, okay? Yeah, that looks kind of good enough, kind of. Now don't bother, and don't be bothered if I kept on saying kind of, okay? For I in 10 characters. 1, 2, oopsie. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because this time it starts from 0, so it still counts as 10 characters. Print. Now again we use the format method. Now, if you wanted to do directly, then that means we should not include a string. But by the way, then we don't even need these curly braces, actually. So, what if we wanted to print some fractions, right? Now, if you put in a slash, this is like the normal way of doing it, right? A slash. Now, if you wanted to do a whole string, then that'll be so much tiring and sweaty. But for this, since the computer will automatically calculate it to you if you don't put it as a string. Yeah, because then it'll automatically know that it's you having to solve, and then it'll bring out the table. So we know that A equal to 6, right? Now, what if we want it to be the... Oh yeah, sorry, it has to be the numerator to change, right? Oh yeah, it doesn't matter. The numerator will anyway change with it. A by 6. So now we're gonna say that A will change by 6 more. So that the amount of holes will be more, okay? Equal to... So now we can put in a string, okay? Because then we'll get confused thinking that there is nothing to function here. And remember, you need this comma or else it'll put out an error that touching something, whatever. Equal to, equal to, actually, never mind, actually. Well, actually, now I have the perfect idea of how to do it. We put in the string first, equal to, so A slash 6 equal to, well, you see, this is just as the same procedure or something, just for, if you want it to be kind of like this. Now, we don't have to do this. Now, it'll automatically put a space for you. Because if you just put in the space, then the comma will also be acquired as a space, actually. It happened to me. I thought it would not acquire a space because it's a string. But equal to a by 6, of course. A by 6 equal to a by 6. But the a by 6 that without a string is going to calculate itself and be an answer. So the fraction equal to the answer. Probably. That's easy form, right? A/6. Now we got to make sure that a is different than 6. A is like one more whole and like one more whole, right? A equal to a. Now, if you put times 2, then it's just going to put it kind of like a times 2 exponent or something. Not exponent, because then it's just going to times 2 up everything. Kind of like binary or something. So you can just put in plus 6. Plus 6. 8 by 6 equal to 1.0. Oopsie, I got to put in floor division. Because then only put integers, yeah. 8 by 6. Now, why is it 8 by 6 coming? Sorry, guys. Okay, so this has to be this. So now we got to print out A. 6 by 6 equal to 1, right? That's true. 12 by 6 equal to 2. 18 by 6 equal to 3. 24 by 6 equal to 24. 24 by 6 equal to 4, so me. 30 by 6 equal to 5. And this whole fraction came up. Instead of having to put something like, kind of like this instead. Well, actually, it was pretty silly, actually. Guys, it was actually pretty silly. We could have just put in the same procedure and instead just change this sign. I know. I did something silly, probably. Anyway, so that's it of how you can do these sort of beautiful mathematical loops and mathematical tables using for loops. And so, bye-bye, guys. See you next time.